Hi class. In this second brief segment, I'm going to discuss a little bit about z-scores. Hopefully z-scores are pretty, are making sense, at least from what you read about in chapter 4 of SPATS. But I just wanted to supplement what's in that chapter a little bit with a little bit of video discussing what z-scores are. First off, z-scores are a type of standardized score, and whenever we talk about something being standardized, typically often what that means is that we are creating a common denominator, or we are dividing something by something else. For example, one of the most commonly used standardized scores that you're probably used to discussing and talking about and hearing about quite a bit is the percent. For example, when you see this, percent, what does percent literally mean? Percent means per 100. And you're probably pretty accustomed to calculating a percent, like if you have had a class where you wanted to find out how you were doing in the class, and if you knew the number of points you had earned and you knew how many points were possible, you simply divide the number of points you earned by the number of points that are possible and then multiply by 100. That's one way of finding a percent. But really, percent is a standardized score. What makes a percent a standardized score? You are dividing something by 100 per 100%. Z-scores are standardized scores as well because we're dividing something by the standard deviation for a sample. Hopefully, at this point in time in the semester, you are very familiar with the mean, the median, the mode, as well as the range, the variance, and the standard deviation. The standard deviation is, as we've already learned, a measure of dispersion. It tells us how spread out a group of scores are. That's what the standard deviation is. If you're confused about that, you need to go back and look at some other videos and review some of the material that we've gotten to so far in class. Because the calculation of z-scores pretty much assumes that you are familiar with the standard deviation and also how to calculate it. This is a handout that is available on Blackboard. So if you haven't yet calculated that, if you haven't yet downloaded that, you might want to do that. Go ahead and pause this video if you want and go print that out or bring it up on your screen. I have as you can probably see on this handout, I've defined several of the terms, but I'm going to use a larger version that I created in order to do that verbally and videoly. Anyway, this is the same formula we just saw. It's the formula for calculating a z-score. Z-scores can be calculated for every score in our distribution. So you'll see when you get to some of the exercises this week, if you haven't gotten to them already, that I'm asking you to make some assumptions. So when we talk about z-scores, assume the following. Assume a set of scores, all right, a set of data. You've already worked with a few sets of data so far within the context of this class. And also assume that you have calculated the mean for those data and also that you've calculated the standard deviation for those data. If you have a set of data and you have the mean for those data and you have the standard deviation for those data, then you are in great shape to calculate each score's z-score. We're using this formula. X is simply any score in your data set. Any score in your data set. So if you were asked to calculate a z-score for the lowest score in your data set, you would look at your data, you would find the lowest score, the one with the least value, and you would plug it in here. That would be your value for x, minus the mean. The mean is simply the mean for the data. So you need to know how to calculate that. Go back and review that if you haven't done that yet. Then divided by the sample's standard deviation. X minus the mean. And by the way, I don't think I've used this term deviation score yet. Maybe I have, but this numerator, X minus the mean, that's referred to as the deviation score. And there's a reason why it's called the deviation score, because it's a measure of how far a score deviates or is different from the mean. That's what a deviation score is, or at least that's what a deviation score is within the context of z-scores. So calculating z-scores is really pretty easy. You simply take any member of your data set, any piece of data, subtract the mean. That is the deviation score. That's the difference between your raw score and the mean, and then divide by the standard deviation. Now, let's talk a little bit about what z-scores then represent. What are we doing with this z-formula? What we're doing, this is very important, we are standardizing the difference between a score and the mean by the standard deviation. I'm going to say that again. We are standardizing the difference between a score and the mean using the standard deviation. One more time. What are we doing with z-scores? We are standardizing the difference between a score and the mean using the standard deviation. What is in the denominator when you calculate a percent? 100, right? Percent, 100. What's in the denominator for z-scores? The standard deviation. That is what z-scores are. Z-scores represent units of standard deviation. Units of standard deviation. So if I said, hey, I had a raw score of 10 and it was a z-score of 1.5. That means that my score of 10 fell 1.5 units of standard deviation above the mean. If I said, hey, I got a score of 85 on the test, and that 85 was associated with a z-score of negative 2.1. That means that my score of 85 fell 2.1 units of standard deviation below the mean. Z-scores are units of standard deviation. More specifically, z-scores are raw scores that have been transformed into units of standard deviation, above or below the mean. There's a handful of handouts and exercises in this week's activities that I hope you find useful. And if you have any questions, please feel free to email me. Again, getting back to something I mentioned in the first segment for this week, I did not mean to be off-putting with any of the emails that I sent at all. I am happy to entertain questions. I am happy to explain things further. I am happy to share any and all resources that I have at my disposal that can help you understand or that will assist with your understanding of these constructs. But one thing I can't handle are a lot of attachments because, again, the email traffic gets really out of control and it's just too hard to keep track of things. And frankly, I'm afraid I'm going to drop the ball accidentally and not mean to, and then it leads to confusion and then difficulty working things out. So please keep that in mind. But if you have questions about content or need clarification or need assistance of any kind, I am more than happy to oblige. All right. Have a great week. And again, you'll notice that, or if you haven't seen it already, you'll notice that the due date for all the activities is not Monday, but Tuesday because I'm of this week. So anyway, take care, and I will hopefully hear from you soon with great success.